Dobar dan. Dobry biti doma. I'm really just auditioning to become your next prime minister. I'll keep practicing. We can practice today. It is great to be here with you today. It's great to be in Croatia, where finally people pronounce my name correctly. And it's great to come and feel of your energy. I arrived yesterday, and I'm here just for a short time. And obviously, there has been a lot of talk of your recent elections and of the prime minister, and many of the conversations I've been in thus far have discussed this. But when I look out at this audience, this is the future of Croatia, right here in this room. It's the entrepreneurs, it's those who are thinking ahead to next year, to 5 years, to 10 years, who are starting to build that future, who are coming up with ideas in their living rooms and in their kitchens, in their garages, and taking those ideas to the world from something that you wrestle with, you think about, you struggle with, you build, you create, you build a team, you build a company. That company becomes an international player, part of a conversation, and that is what drives economies forward. And that's what I see before me today. I see energy, I see excitement, I see ideas that are ready to be formed. And certainly that's what we try to do at CES, is take the best ideas from all over the world, from every industry, and bring them together into a single place. And we've done that with a number of things. If you think about what we have with automotive, the automotive space was 200,000 square meters. To put that into perspective, that would be, if it were a show, a fair all by itself, would be one of the 100 biggest fairs in the United States. And it's just one little part of what CES is. CES 2016 set records across the board. And next year, as we head to Las Vegas, it will be our 50th birthday party. So I encourage all of you to come to Las Vegas and help us celebrate. What I want to do now is talk a little bit about what that future looks like, the future that each one of you can build, the future that each one of you can start to put together. I want to talk about the building blocks that have come together and built the platform that we're on today, and ultimately what that future starts to look like. So let's step back and let's think about where we've come. Let's think back and specifically about data. If you think back to 1890, Herman Hollerith, he had gotten a PhD from Columbia. He was living in Washington, D.C., working for the Commerce Department. And at the time, the Census Bureau, and at the time, one of the big struggles was the census. The 1880 census had taken 8 years to complete. They were getting ready to do the 1890 census, and the concern was that it was going to take over 10 years to the census, so that the census would actually be done after the time they would need to start the 1900 census. Herman Hollerith came up with a simple machine, a tabulation machine, that would allow them to read data, organize it, analyze it, and it cut the census down from an 8-year process to a 1-year process. He began to manufacture those machines in a little neighborhood of Washington, D.C. called Georgetown. For those of you who have ever been to Washington, D.C., you know it's not the manufacturing metropolis that it apparently once was. And those machines began to ship all over the world. They shipped to census bureaus in Europe. They shipped to census bureaus other places. That company would merge several years later with 3 other companies to become IBM. So from a simple idea, solving a simple problem, one solution, we see a large multinational corporation being born. Stepping forward, 1942, we get the first digital computer, the ABC. But it wouldn't be for another 40 or 50 years till the idea of home computing, digital computing in our homes, would become a ubiquitous idea. We step forward, 1956, IBM introduces the first hard drive. It's about the size of a refrigerator. But it wouldn't be until the 90s that that would start to become a ubiquitous idea. Storage being readily available, digital storage that we could store all of this information on. 1967, the first CES is born in New York City. It would continue to grow until Las Vegas really is the only city in the United States big enough to hold it, with enough exhibit space and enough hotel rooms. Just to put things into perspective, 3 of the largest convention centers in the United States are in Las Vegas. CES uses all 3 of them. 1967, we also have one of my favorite stories. Richard Greenblatt is a professor. He writes a very influential paper about artificial intelligence. At the time, we were using artificial intelligence to do logical protocols and logical experiments. We were doing it to write things like chess programs. Professor Greenblatt, in that paper, wrote that the chess programs of today can't even play amateur chess. He compared AI to alchemy. It would be 2 years later, in 1967, that Richard Greenblatt would challenge Professor Dreyfus to a chess match on a chess program that he wrote for a digital computer with 16 megs of RAM. He would, of course, go on to beat Professor Dreyfus in that chess match. Just 2 years after Professor Dreyfus said, these chess programs can't even play amateur chess. So we see that sometimes technology and innovation takes decades to come to fruition. The first digital computer in 1942, but it's not until the 80s that home computing becomes ubiquitous. The first hard drive in 1956, but it isn't until the 90s that storage becomes ubiquitous. And yet, at the same time, some things start to happen very, very quickly. Amateur chess programs become professional chess programs, become very good chess programs. In 1980, McKinsey comes out with a very influential quote, a very influential study, with a prediction that 20 years from that point, in 2000, there would maybe be about 900,000 smartphones in the United States. By 2000, there were 100 million smartphones in the United States. Today, there's over 330 million smartphones. And like Croatia, you see more mobile subscriptions than people. It was only a few years ago that we thought that that would be possible anywhere in the world. And at the time, we said, maybe it makes sense in a place like Hong Kong, small, concentrated population, densely populated community with unique characteristics. You've got a large percentage of the population traveling across country borders at the time, and so maybe it makes sense that they would need 2 mobile subscriptions. But we see that that has grown to be a widely held view. Most countries in Europe now have more cellular subscriptions than people. And that's true also, as we've seen in the United States. Stepping forward, 2007, we get Apple introducing the original iPhone. And this is an important time period for innovation and for technology. 2006, Nintendo launches the Wiimote. And the Wiimote is one of the first products to take sensors and embed them in consumer-facing products. So prior to that point, we were using things like accelerometers to deploy airbags. We were using them to control missile systems, but we weren't using them in consumer-facing products. So then we started to put them into consumer-facing products, the first being the Wiimote, which allowed the individual to digitize their physical movement, their physical motion, and incorporate that into the gameplay. The same innovation, the same technology was built into the original iPhone, and the primary purpose at that time, in 2007, was simply to change the orientation of the screen, to switch it from portrait to landscape mode. It would add about $15 to the bill of materials, to the cost of the good being produced. So about $7 for the x-axis and about $7 or so for the y-axis. Today, we don't even price accelerometers in terms of degrees of motion. You get the entire chipset, and the price points are well below $1 for the entire thing. And so we see how quickly innovation becomes inexpensive, and then as a result, how we can deploy it widely. And I think that's a very important premise, that when something moves from an expensive scarcity to an inexpensive abundance, we waste that. And when we waste that, we start to change how we use that technology. 1981, Xerox introduces the Xerox Star. It's the first computer to use a graphical user interface. At the time, the price point is $75,000 US. It doesn't see a lot of people buying it. It doesn't have much market potential. It is essentially ruled a failure because nobody buys it. 3 years later, Steve Jobs would take what he learned from Xerox, incorporate it into the original Macintosh, launch the Macintosh at about $2,500. It would become the first computer to have a graphical user interface that would go on to see commercial success, commercial viability. Now, think back to the time that we were using computers in the 80s. We didn't need a graphical user interface. We could navigate that computer environment just fine. The graphical user interface was essentially a redundant feature. So what happens between 81 and 84? Computing prices go down, computing power goes up. Moore's law kicks in a major way during that time period. And so what was and had been a redundant feature can now become standard across all computing environments and changes the way we navigate the computing environment. So we could have navigated it with the command windows and command prompts, and instead we start to use graphical user interface. And so slowly over time we see that shift incorporated into everything we know. And today most of us only operate computing environments with a graphical user interface. So now let's step forward. We've looked at some of the history, now let's look at what's coming and what that future starts to look like as we take these things together. As was mentioned, I published a book last year called Digital Destiny. And in it, I provide what I call these 5 pillars of digital destiny and of our digital data. They are ubiquitous computing, digital storage, and connectivity. So let's just look at those first 3. I talked about the first digital computer we had in 1942, but it isn't until 1981 that we see the next consumer digital device. 1981, Sony launches the CD player at CES. So it's 40 years from the time we see the first digital computer till the time we see the next digital consumer device. And then it would be, again, not until 1998 that we see the third digital device. 1998, we sell the first digital television. And then, in quick succession, starting with that first digital television, we began to replace all of our analog products with digital ones. 1998, you look at places like the US, only about 3% of households are on broadband at this time. Most people who have home internet connectivity are still dialing up. We were going online and we were coming offline. It was an activity. It was a different state, if you will. And then, in 1998, as I mentioned, we sell the first digital television. 2001, we get the original iPod. We start to replace our analog tape players with digital ones. 2003, we get our first smartphone from BlackBerry, so we start to replace our analog phones with digital ones. And it continues, replacing analog cameras with digital ones, replacing all of these other analog products with digital ones. We spent about a decade doing that for all of our core devices, televisions. Computer ownership goes from 40% in the US in 1998 to 85 to 90% today. And that same trend has played out across the world, from Croatia to Hong Kong to everywhere in between. We've seen a massive uptake in digital devices. Storage goes from something that's scarce to something that's in abundance. When was the last time you went onto your computer and deleted things because you were out of storage? We used to do this all the time, not that long ago. We would go and we would delete files because we had run out of space. Now we just get bigger hard drives, we store it on external hard drives, we store it on the cloud, we move documents around, the way we interact with this digital data is different, so we might not even save it locally. All of that shift has happened in just the last couple of years. So the advances that have taken place in the last 18 months far surpass the advances that we saw over the last 50 years combined. One of the great examples that I like to point to is voice to text. Voice to text was first introduced in 1995. And the way we measure the accuracy of voice to text is with something called the word error rate. How many words come back as an error? 1995, it's almost 100%. Right? The systems were horrible. You would say something and it wouldn't pick up anything that you said. By 2003, we've improved it to about 25%. So 1 in 4 words come back as an error. And then in the next 18 months, so in the last 18 months, we take it from 25% to 5%. So now only 1 in 20 words come back as an error. In the last 18 months, we have improved that technology more than in the first 20 years. I think that same trend is playing out across the board. All of these components, all of these things are coming together today, and they've all come together in just the last 18 months. The last points that I would make would be, connectivity, the proliferation of digital devices, sensorization, and it's really those last couple of things that have come together in just the last few years. As I mentioned, 2006 with the Nintendo Wii, 2007 with the iPhone, were the first consumer-facing products to embed sensors. Prior to that point, we weren't using them in consumer-facing applications. And now you would be hard-pressed to find any consumer-facing products that don't have sensors embedded in them. At CES, we saw a number of products that are embedding multiple sensors. Obviously, your smartphone has multiple sensors, but there were a number of other products that have 15, 16 sensors. That isn't uncommon. That would have been unheard of 10 years ago. And now we take that as given. So the ability to digitize, to connect, to sensorize these environments is, I think, a very important element of what's moving forward. And again, think about how the digitization, the connection, and then importantly, the sensorization changes that environment. Mobile phones. We include 1 image sensor on the back of your mobile phone because it's expensive. As price points come down, as economies of scale go up, we then start to include a second image sensor on the front of your mobile phone. Because we can start to waste that technology. And what happens when we include an image sensor in the front of your mobile phone? Selfies, right? And we can argue if that's a good thing or a bad thing, but it fundamentally changes the way we use that device. I was just out at the main square out here, and I saw the little display that was out there. Nobody was taking a picture of it without including themselves in the picture. Every picture I saw being taken was a selfie. That wasn't possible in 2007 when we launched the original iPhone, or it was cumbersome to do. And so by including a second image sensor, we're able to make that a more seamless, fluid, enjoyable experience. And the reason we include that second image sensor is because price points went down, and we were able to essentially waste that sensor. So the smartphones I see today, the prototypes I see today for smartphones include 2 image sensors on the back and 1 on the front. So with 2 image sensors on the back, you can start to do 3D imaging. You can start to digitize tape measures. You can start to digitize other information. And that's what happens when we digitize these objects, we connect them, we embed sensors into them. We can start to digitize additional information. Information that was already there, but wasn't being readily used. And it's really those last 3 points, the digitization, the sensorization, and the connection that I think really drive us forward into the next decade. And we are sensorizing everything. You can see the surfer here. It looks like your regular surfer. Notice the black box right there on the end of the surfboard. That's a sensor unit. Includes in it the same sensors that are showing up in your iPhone, the same sensors that were built into the Wiimote. And with that, now we can measure things like wave height, how fast he was surfing, so the speed, where he did his bottom turns, how long the ride was. All of the information that was already there, but wasn't being captured in a very systematic way. It wasn't being collected, it wasn't being analyzed, it wasn't being stored. And so now all of a sudden we can start to capture all of that information. Where do we go next as we start to capture all of that information? As we start to digitize information that was already there but wasn't being readily utilized. Simple baby onesie. This was launched at CES a couple of years ago. It's a company called Mimo. And you'll notice that it's got a little green turtle on its hip. In that green turtle are a number of sensors. It has a temperature sensor, so it tells you the temperature around the baby. It has a digital microphone. Digital microphone is another sensor that went from expensive to inexpensive, so we started to waste it. Most of your mobile phones, if you were to pull them out, will have two microphones on them, one to capture your voice and one to capture the noise around you and to cancel it out. So increasingly, we're embedding multiple microphones on your smartphone. Soon we're going to have 5 or 6 digital microphones on your smartphone, because right now phones do really well when they're parallel to your mouth. They don't do great when they're non-parallel to your mouth. But if you have 6 digital microphones in that, then you can triangulate where the voice is coming from and improve the call quality. So by deploying more sensors, we improve the experience. In this, we have an accelerometer, so you can tell whether the baby's awake, whether it's asleep, whether it's on its stomach, whether it's on its back. That accelerometer connects to the green stripe, so you can tell whether the baby's breathing or not. It has built into it a digital microphone, as I mentioned, so you can hear what's happening around the baby. It has Bluetooth, and so it sends all of that information to your mobile phone, so you can monitor the baby in real time. And you could imagine that over time, we'll start to tie all of that information into a bigger system. So if the baby were to stop breathing, emergency numbers would be dialed, the doctor would be alerted, the ambulance would be alerted, lights might go on, the front door would unlock. If you were sleeping, maybe alarms go off. All of these things can be triggered simply by digitizing the information that was already there, but just wasn't being captured in a very systematic way. So as you think about what that future looks like, think about where information exists that isn't being captured, that isn't being utilized, and how sensors might unleash that data and unleash that information to power environments. So one of the things I talk about in the book is the idea that we take what's happening in the physical environment, we digitize it, and then ultimately it has to feed back into the physical environment in which we live. This is the diagram that I use in the book, and it talks about, you can see we have this analog activity, steps, walking, probably the easiest example. We digitize that through devices like Fitbit and others that then tell us how many steps we took. But if it doesn't then inform and influence change, if it doesn't cause us to change the way we eat, how we sleep, where we walk, chances are it's not something that's going to resonate with the consumers. It's not something that's going to feed back into our daily activities. So that's another important thing as we start to build this future that lies before us, thinking how the digitization of information flows back into the physical world in which we live. Because if it doesn't change the way we live, chances are it's not something that will resonate. Had the image sensor on the front of the mobile phone not changed the way we lived and the way we used that device and the way we communicated with one another, it's probably not something that would have had much longevity, wouldn't have stayed around. We would have discarded it because it wasn't influencing our daily lives. And that's the beauty of CES. You've got 20,000 products that launch, services, experiences at CES. Some of them will fail. Some of them aren't going to resonate with the consumers, but some of them will succeed beyond our wildest imagination, beyond our wildest dreams. It will fundamentally change and shift the way that we communicate, the way we interact, the way we work, the way we play. All of these things can be influenced simply by digitizing information that was already there. And we can start to really customize these different environments. There's so many different products that we could point to. I love the idea of transparent LCD screens. So you could imagine that you put transparent LCD screens in a storefront, and then you could change the prices. The prices could be based upon inventory. The prices could be based upon the supply and demand characteristics that are unique to that location. Advertising could be pushed to that window immediately. So if you had endorsements with major sports figures, you could then push that video clip of them scoring the winning goal in football, or scoring a touchdown in American football, or whatever your sport is. That video clip could be immediately sent to the product. You could tie that screen into the delivery truck. And if the delivery truck got a flat tire, and we would know this because it has sensors built into the tires, then you could hold the prices steady. And as the delivery truck is repaired and as it backs into the car, as it backs to the back of the store, the price of your milk or your eggs or whatever else is in that truck starts to decline, such that you sell out of your product just as new product is being stocked. So you have this much more fluid environment, more dynamic environment. And I think that's where we start to go as we digitize this information, as we move into a very dynamic environment. The way we interact with computers is changing. We used to communicate with punch cards, and some of you probably remember using those. Then over time, we added keyboards, we added a mouse. Some of you might recognize this. This is the graffiti language that was introduced by Palm with their Palm Pilot. And you can see it looks like the alphabet we know. The A kind of looks like an A, but not quite. The B looks like a B, but not quite. The G is capitalized, but the H is lowercase for some reason. And it's because it's what the computer needed. It was a hybrid language between the way we communicated and the way the computer could interpretate that communication. But over time, as I've mentioned, things have gotten better. We can now use voice, we can use gesture. The way we interact with computers is changing. You know, when Apple introduced their watch, one of the defining characteristics is that it could send your heartbeat to somebody else. Do I want somebody's heartbeat? I don't know. No, do I want all of you in this room to send me your heartbeat? Probably not. But if that's an experience that resonates, if that's something that's meaningful to somebody, then it fundamentally shifts and changes the way they communicate. And so we're in this period of experimentation right now, and I think it lasts for 5-6 years. That's why it's such a ripe time to innovate and to be an innovator, because we don't know what's going to resonate. Some of these things will resonate, some of them won't. Some of them will resonate beyond our wildest dreams. And we're developing this Internet of Me culture. And I'll talk a little bit about what that Internet of Me looks like. And think about wearables. This is Hugo Gernsback, personal TV viewer. We've been thinking about wearables for a long time. Right? This one didn't quite stick. I didn't see many of those as I was walking over here. People tripping over each other because they were watching TV. I didn't see very many of those, on the airplane. At the end of the conference, when you get to watch Silicon Valley, you're not going to be handed a bunch of these, right? So some of this personal viewing has shifted. But one of the things that happens is as we digitize these environments, we can fundamentally change it. So autonomous vehicles, we talk a lot about autonomous vehicles. What does autonomous vehicle mean? It means that you don't have to have a steering wheel in front of you. It means that you don't have to sit forward. And so if I don't have to have a steering wheel, I don't have to sit forward, I could do anything. I could put a bed in there, I could put a desk in there, I could put a hot tub in there, I could put an infinity pool in there. You can do anything you want inside that vehicle. You can customize it, you can change it, because you don't need to have a steering wheel. You don't need to have a brake pedal, you don't need to have seat belts. You can live further away than you might have wanted to. You could live closer than you might have been able to in the past. Everything changes because we digitize that environment. And if you think about what an autonomous vehicle is, it's your typical vehicle with sensors deployed all around it, right? Connecting sensors to the vehicle. This isn't a dream. This is the reality. This is the reality you see at CES. These are here today. The technology hurdles have been overcome, and now it's just a matter of getting the technology to a point that it becomes affordable for the average consumer. It's something that can start to deploy. I think in 5 years, we'll start to see these become available to consumers. And then over time, we'll grow from there. 1.7 billion PCs in the world, 2 billion smartphones. That's something that's just changed in the last 18 months. For a long time, the only way we interacted with the internet was through a browser. And if you go back and you look at the original mobile phone experience, it was completely focused on the browser. But we learned that that wasn't the type of experience we wanted with the mobile phone. And so what happens as we go from 1.7 billion PCs to 2 billion smartphones to 50 billion connected objects? What does the home page for the internet look like? What does the internet start to look like? And that's the experimentation that's before us. And we talk about smartwatches, and what I hear today still too frequently is, let's talk about the smartwatch as a device. I think that's the wrong approach. I think what we want to look at is, does the internet make sense on the wrist? And if the internet does make sense on the wrist, then what's the use case scenarios? What's the meaningful experience for the consumer? Is it alerts? Is it text messages? Is it incoming phone calls? Is it something completely different? Is it payments? Does the internet make sense on the wrist? Is it health and fitness metrics that are shared with a doctor remotely? Any number of these things all of a sudden become available to us simply because we've deployed the internet to our wrist. So where else should the internet exist? Should it exist in drones? Should it exist in our cars? Should it exist in our doorknobs, in our lights, in our seats? All of this information becomes available to us as we start to deploy sensors, we start to connect it, we start to deploy the internet. So where should the internet live next is really the question before us. Let me close with just a simple example of what this might start to look like. Netflix is coming to Croatia, right? This was an announcement made at CES. And so most of you are probably already familiar with Netflix. It allows you to stream movies through their collection. And they have an interesting algorithm. And they focused a lot on that algorithm around making recommendations. So they look at some basic demographics about you. They then take those basic demographics and they look at what you've watched, your viewing history, and they map that to what other people like you have watched, and they make recommendations. Things they haven't watched that you have become a recommendation for them, vice versa. Things that they've watched that you haven't become a recommendation to you. What if they had access to your thermostat so they knew how hot it was or how cold it was outside? What if they had access to the cameras in your home or the microphones so they knew how many people were there, whether you were sitting up, whether you were lying down, whether you were standing, whether there were 6 of you, whether you were alone? And what if they had access to your wearable device so they knew how excited you were, how stressed you were, how depressed you were? Now all of a sudden they can look and they can say, hey, Shawn, we see that you're alone, it's dark, it's quiet, you're on the couch, you're lying down, you're depressed, somebody's crying, So that's right. I mean, they can start to make these recommendations based upon that environment, right? Maybe it's the example I love to give is the Nicholas Sparks movie. All of a sudden it says, hey, here's something you've never watched before. This is completely out of your genre, but it fits this environment. And so I think we'll start to look at these environments, start to make recommendations based upon the environments as opposed to historical patterns. Most of you are familiar with Twitter. And one of the things that Twitter allows advertisers to do is advertise to individuals based upon gender. But Twitter never defines your gender. You don't say whether you're male or female when you sign up for Twitter. They don't know with certainty what your gender is. It's digitally defined. It's based upon how you use the program, the type of people you follow, the way you write, the type of things you write. All of that defines your gender. So the digitization of this information will start to define these environments. So in closing, here are the things I think we're looking at for 2016. What do we digitize next? If you look around you, we're still living very much in an analog world. We have a few digital devices around us, but if we're going into an environment with 50, 60, 70 billion connected objects, then we need thousands of connected objects around us, in our homes, at our workplace, in our vehicles. And so what do we digitize next? How do we connect it? What's that connectivity look like? Where do we embed sensors? And then most importantly, what's the use case scenario look like? How does it change the life we live in the physical world in which we operate? How does it change the way we communicate, the way we work, the way we do all of these other activities today in an analog world? I think these are the broad questions before us. The environment is extremely ripe. All of the building blocks are there. Digitization has become available to us. Connectivity is there. Sensor prices have dropped so that we can deploy sensors widely. And it's empowering and enabling a tremendous number of opportunities. Certainly CES highlighted that. I think you'll talk about those things today. And so the opportunities that exist before us are extremely powerful. We have the capability, like no time in history, to redefine our future. And that is the challenge that is before us. To take the building blocks that are here today, before us now, and redefine the future that lays ahead. Thank you very much.